Hey, I tried to find solid data about AV1 compared to x264 and 65, and also hardware accelerated AV1, but I couldn't find much, so I had to make my own comparison. So here we have a bit of data to go through. I made a 20-second test clip and encoded it with Handbrake and collected all the data to Excel. All these encodes and data are available to mess with if you'd like. Link to download is in the description. Well, what is Handbrake? It's a quite nice application for transcoding and re-encoding videos. Handbrake has a lot of options, but for this we only need few functions. These are encoder preset and constant quality slider. This will be the option most affecting file size and quality in the end. And the encoder preset correlates directly how good compression Handbrake can do while taking more time. More time equals better quality, and we can see these results later. Okay. So here we have a timeline. I've added all the files to the timeline, as you can see. I've stacked the files that have matching, at least close as possible matching bitrates. So we can easily compare the files with same bitrate with just a one click. With Intel AV1 hardware accelerated, you can choose preset from speed, balance to quality. All the encoding times are the same, and as you can see here, the difference is, well, there is a difference. This is speed, balance, and quality. Speed, quality. So there is a difference, and the encoding times are pretty much the same, so I don't see any reason not to use the quality one. Okay, here we have the first comparison between Intel hardware accelerated AV1 and x265. Both of these files are roughly 390 kilobits per second. That is extremely low for 1080p 24 fps, as all my encodes are 1080p 24 fps. So, under the matching bitrate encodes, we have the baseline test clip. This was the highest possible quality I was able to get out of Resolve. So we are comparing between matching bitrates, but also we are checking how much we lose detail. And in this comparison, it's a lot. Here is Intel AV1, a lot of blockiness, artifacts, little bit flashing. It's not good, but it's decently bad. Like, it's bad all around. And then we move to the x265 and play it again. I would say Intel AV was much better, because x265 has weird artifacting and I don't know what's happening, but it doesn't look good. So I would say the winner is Intel AV1. Let's color it green. And there we go. Okay, next up we have close to 530 kilobits per second. Intel AV1 again, and this time x264. Intel AV1 looks pretty much the same. Little bit higher quality as there's a little bit more data going around. But when we compare it to the x264, well, Intel is the winner again. This is just interesting what's happening on the screen, and it looks bad. Next, we are close to 900 kilobits per second. Here we have Intel again, Intel up here, a little bit higher kilobits. Also, we have SVT AV1. This is AV1 done in CPU, so no hardware acceleration. Also, we have Resolve Intel AV1. This is Intel hardware accelerated, done in Resolve, so no Handbrake used here. So instead of making the test clip, putting it to Handbrake and making Intel AV1, Resolve can do the same in the software. If the Intel AV1 will be the best, you don't need Handbrake, you can just do all in Resolve. First, we are comparing SVT AV1 50, that's the quality, preset 5, to Intel AV37. The bitrates are matching. We move to scene where is a lot of movement and we can switch through them. So this is SVT, Intel. SVT again, and Intel. Intel has again more blockiness. Overall, I don't like it as much, and as you can see, the snow gets frozen on the screen. So when we play it looks decent, but not good. We check with the SVT. Well, it doesn't look good either, but it's a little bit more clear. With SVT, I don't see as much of freezing snow on the screen. The snow comes, the snow goes. But with Intel, we can spot, for example, this snow above the yellow. It just stays there. Same here. And here. And here for a second. So, yeah, I don't like it. It looks bad. We switch to SVT. The snow doesn't stick. Little bit here for a frame, but it's much better. It's clearer, cleaner, and better. But it's quite flashy, and I don't like it. We don't have much detail. So when we compare to the original one, yep. So the preset 5 was better. But what about all these files here? When we move down the preset list, it takes more time, but it looks better. So from 5 to 3, we get more details, less blockiness, looks better. From 3 to 1, again, it looks better. And the slowest one, well, it's the best. Especially when we watch the video. The snow is nice, a little bit flashy and flickery, but it's not bad. Comparing to preset 5, where it's really flashy and flickery. And that's not pleasant to watch. Preset 3, it's still flashy. Not quite as bad as the 5, but compared to the slowest one, it's still bad. This is better. So the winner from this is SVT AV1 slowest preset. Let's make it green again. But when it comes to the time the encoding takes, Intel is the clear winner. We will see more about this later. Here we have Intel AV1 and Intel AV1 done in Resolve. These should be quite identical, except Intel AV1, this one, is done from the test clip I made in Resolve. And the Resolve Intel AV1 was done from the source files in Resolve. So one less step, and technically this should be quite identical, but not fully identical. So when we compare Resolve to Handbrake, we can see a little shift, but nothing major. It's almost identical. I would say if you're using Resolve like me, and you want to use Intel AV1, just use Resolve encoding straight to Intel AV1, instead of making a high quality clip and taking it to Handbrake and making Intel AV1. So, comparing Intel AV1 to SVT, the slowest preset should win again. And it will. It applies to the previous one and to the next one. We enable SVT AV1. We see all these details come back here. We lose all the blockiness that we have here. And it's just much more cleaner look. And when we climb the presets, the same happens. We lose details, but the encoding time is faster, and so on. When we compare to x264, we actually have way more details here. This is SVT and 264. The snow seems like it's not flickering, it's there all the time. The 264 actually has a lot of grain and noise we don't like. All this doesn't look good. Then we switch to SVT. It's clean. Main details are there. It may be a little soft compared to 264. But the ugly sky here and the ugly snow, to me this is unusable. When we compare to the SVT, it's clean. It doesn't seem so detailed, but it's so much cleaner than 264. One more time, 264. All this grain and ugliness on the sky compared to SVT. one more time. So the SVT is the winner here again. What about 265? It gets better. 265, SVT again, 265. We have more details. Something weird happening here and here. And this is the slowest preset with 265 possible. You can see these artifacts here, here, here. These lines compared to SVT, it's just clean. We lose quite a bit of detail from here, for example. But it just looks cleaner, and we don't quite need those details when we are also getting this grain and blockiness. X265, quite blocky, and I don't like the colors, how they go. When we compare to SVT, it's a little bit softer, but it's more consistent. So I'd say SVT wins again. Let's make it green. So SVT AV1 has been the best. Slower the preset, the better the results. We can even see this from the Excel I made. Here we have the SVTs in yellow. Orange is the Intel AV1, x264, 265. Below this we can see a score. So higher is better. This is from ssimulacra2. It's a program comparing our test file, so the baseline file, the highest quality one, to the encoded ones. And it will give us a score that we can add here and compare. So higher score is better. On the y-axis we see kilobits per second. So higher we are, the higher the file size is, and most likely higher the quality. But here we are actually already scoring high, roughly 68. When we go up the same line, we are meeting with Intel AV1 quality set to 29. And this is actually 4,379 kilobits per second. Meanwhile, our SVT AV1 is 2,200 kilobits per second. And we are matching the score from ssimulacra2 between these, even though the kilobits per second is almost double. So let's take 29 and compare Intel AV1 quality setting 29 to SVT AV40 preset 0. So now we are comparing almost double the bitrate to the SVT AV1 slowest preset. Intel still has these artifacts here all around. While we switch to SVT AV1, it's just clean. Couple frames ahead, switch again, SVT wins again. Let's go closer. I still say SVT looks better, even though Intel AV1 has double the kilobits per second. So let's say if our SVT AV1 file is 20 megabytes, our Intel AV1 29 is 40 megabytes. So that's insane. So when we go back to the chart, SVT seems like a clear winner. So for me, SVT AV1 30 preset 0 is the best. The size is roughly 6000 kilobits per second. The score is high. 265 wasn't good, 264 wasn't good. Going higher, the score doesn't really rise, but the size of the file is going really fast up. So I think these are the ones I'll be using. But when we go back to Resolve, we have another video here using the same quality setting 30, preset 3. We are actually hitting 16,000 kilobits per second. Meanwhile, with the test clip SVT AV130 preset 3, you're hitting 6,000 kilobits per second. So what's happening here? The quality setting is trying to keep the quality as the same. As this is from a mobile phone, the quality is not there compared to like a proper camera with good pixels and so on. So this actually ends up being higher video than from my camera with the same settings, because these pixels need more kilobits per second to get the same quality in Handbrake. For this video this is kinda bad, 16,000 kilobits per second. Well, the last video, clip of a longer talking session here. The speaker is moving, drawing, people on the front are moving. I ended up with 17,000 kilobits per second. That's 10 gigabytes. I used preset 3, quality setting 30, ran it through the Handbrake, and now it's 1000 kilobits per second. So here we have 17,000 kilobits per second, and here we have 1000 kilobits per second. And I honestly can barely tell a difference. And something like this, somebody talking, still image, getting it down to 1000 kilobits per second is really nice. It still looks really good. Actually even cleans up the noise in the background. This is the source file. All this noise is here. We switch to SVT AV1. It cleans it up. Little bit something happening with the hand, as you can see here. But when you're watching it, you can't really see it. And also it doesn't matter with this context. So from 17,000 kilobits per second to 1000 kilobits per second. While this one was 16,000 kilobits just because the pixels and movement needs it. And our test file, the 20-second test clip, somewhere in here, ended up being 6000 kilobits per second. But the quality is the same. And I think for me, setting 30 is actually the sweet spot. Sadly, with Intel AV1, the quality was not enough for me. There was plenty of artifacts and things I didn't like. But the speed that the encoding takes was roughly 4 seconds for a 20-second clip. And that's insanely fast. Meanwhile, with SVT AV1, quality setting 30, we had an acceptable loss of detail, we had an acceptable file size, and the quality overall was great. The slowest preset was the best, but we cannot use it because it takes 5 hours for 20 seconds of an encode. This takes way too long, uses way too much power and makes no sense. If we move down to preset 1, the quality was still almost identical. The encoding time goes down to 1 hour, but this is still same case as with the upper one. It's too long and makes no sense. So I ended up using SVT AV1, quality setting 30, preset 3. Quality setting between preset 0, 1 and 3 was quite identical. We get the encoding time down to 12 minutes with Ryzen 2700X, but with different CPUs you can get it faster. For this I did a small test with couple different CPUs, you can see here, and checked how long it takes to encode the same file with same settings, and the results are here.